Hello everyone. So today we are going to learn about two-port networks. A two-port network is an electrical network circuit that has two pairs of terminals, that is inputs and outputs, which are commonly referred to as ports. Two-port networks are widely used in electrical engineering, especially in analyzing systems such as amplifiers, filters, or transmission lines. So there are some parameters which define the two-port networks. Some of them are: first is Z parameters, which is also known as open circuit impedance parameters, in which V1, V2 are expressed in terms of I1 and I2. Second, Y parameters, which are also known as short circuit admittance parameters, in which I1, I2 are expressed in terms of V1 and V2. Third is hybrid parameters, which is also known as H parameters, in which V1, I2 are expressed in the terms of I1 and V2. ABCD parameters, which are also known as transmission parameters, in which V1, I1 are expressed in terms of V2 and I2. So let's take an example. The question is, find Z parameters of the following two-port network. So this is the circuit given and we have to find the Z parameters. That means the two equations in which V1 and V2 will be expressed in terms of I1 and I2. So for finding this, let's apply KVL at mesh 1. So by applying, we get V1 minus 2I1 minus 5I1 plus I2 is equal to 0. So by solving this equation, we get V1 minus 7I1 minus 5I2 equals to 0. And finally, taking the negative terms on the right side, V1 is equal to 7I1 plus 5I2. So we have got the I1 and I2 parameters. Now let's find the parameters in terms of V2. So here, by applying KVL at mesh 2, we get, see here, V2 minus 4I2 minus 5I1 plus I2 is equals to 0. So here it is. So expanding this equation, V2 minus 4I2 minus 5I1 minus 5I2 equals to 0. That is V2 minus 5I1 minus 9I2 equals to 0. And finally, by taking the negative terms to the right side, we get V2 is equals to 5I1 plus 9I2. So here we get the I1 and I2 in terms of V2. Thus the two equations are V1 equals 7I1 plus 5I2 and V2 is equals 5I1 plus 9I2. So here are the four Z parameters. So the parameters are expressed in terms of a matrix where the Z parameters are 7, 5, 5 and 9. Another topic which we are going to see is the filter circuits. Filter circuits selectively allow the signals of certain frequencies to pass through and attenuate or block the other signals. Let's see the types of filters. First is low pass filter. Low pass filter allows low frequency signals to pass while attenuates the high frequency signals. The signals which are less than the cutoff frequency will be passed through the low pass filter, while the signals greater than the cutoff frequency will be attenuated. The opposite of that is high pass filter, which allows the high frequency signals to pass while attenuates the low frequency signals. The third one is band pass filter. As the name suggests, it allows the signals within a band or a range of frequencies, while it attenuates the signal outside the band. The opposite of that is the band stop filters, which attenuate the or stops the frequency signals within a specific range, while allows the signals outside the range to pass. So these are some types of filter circuits.